As we already learned how horizontal asymptotes related to the limits at the infinity, then we can apply that knowledge into finding the limits at infinity of rational functions. So let's look at a general rational functions f of x. You know that the numerator is a polynomial functions of degree n with the leading coefficients a sub n. And the denominator function is a polynomial functions with degree m with the leading coefficients b of m. So there's three cases in rational functions. Let's discuss the first case when n is less than m. That is when we have one horizontal asymptote, which is y equal to 0. That leads us to the information that we have the limit of f of x when x goes to either positive infinity or negative infinities will be equals to 0. An example of this case is the limit of these functions 2x squared minus 1 over x cubed plus 2x minus 1. So in order to figure these questions out, we need to identify the degree of the top, which is 2. The leading coefficient is 2. The degree of the bottom is 3. The leading coefficient is 1. Clearly, n is less than m, so we can conclude that the limit of these functions when x goes to infinity is 0. And the second case is when m equals to n. In this case, we have also one horizontal asymptote, which is y equals to the ratio of a sub n divided by b sub n. And that leads to the limit of the function when x goes to positive infinity or negative infinity is a sub n over b sub n. Well, an example of this case is the limit of these functions when x goes to negative infinity. Is we know that the degree of the top is 3, leading coefficients is 3, the degree of the bottom is 3, leading coefficients is 4, n equals to m. So then the limit of this function when x goes to negative infinity should be 3 over 4. Alright, how about when n is greater than m? In this case, we have oblique and oblique asymptotes. And the function of this asymptote is a polynomial function with the degree of the difference between n and m. And in this case, we have infinite limits. All right, an example of this case is, what is the limit of x goes to negative infinity of negative 5x4 plus 3x divided by 4x cubed plus 2x squared minus 3. We identify n equals to 4, a sub n equals to negative 5, m equals to 3, b sub m equals to 4. N is greater than m, and the limit of this function when x goes to negative infinity is positive infinity. How will you know it is negative infinity or positive infinity as a result? Because you have two options, right? So you would want to look at the leading terms of the top and the bottom. And you want to simplify these leading terms, and it's simplified down to negative 5 over 4 times x, because x to the fourth divided by x cubed, which is x. And this is a linear functions. And you can see that in these linear functions, you have the negative slope, which is a decreasing functions. And if you have a decreasing linear functions, when x goes to negative infinity, the y goes to positive infinity. So that's why the answer for this limit is positive infinity.